want to go into the graphs and the mathematics around alternating current generators, AC.
Sorry, my phone is
Okay. The example we had in class this morning, we drew a graph that looked like this. Am I right?
Yes.
So this is your current graph. This is the maximum current in the one direction, and this is the maximum current in the opposite direction. Okay. What do you think would a potential difference graph or an EMF graph look like? No.
Potential EMF compared to?
Will current and voltage, will current and potential difference not be directly proportional to each other?
Granted that resistance is the same.
Yes, but it will have. So we have V equals I times R, am I right?
Yes.
Where the resistance of the coil would be constant, am I right?
Yeah.
So the voltage will always be directly proportional to the current. So it will also be, what do you call a graph like this? Sinusoidal. A sine graph.
What the?
It's a sine graph.
Oh, yes.
Oh, okay. Sine graph. That makes sense.
It's a sine graph.
Yeah.
Where does the
And
sine come from then?
it's the shape of the graph. It's a sine graph. Can you please switch that off?
Yeah, please.
I'm putting this so that the whole world can see. And it's not a circus.
Someone's
Okay. Whose value will be the biggest? The voltage or the current? Which one will have the biggest value? If you look at Ohm's law equation, which one will be the biggest value? The voltage. So the potential difference. That is your induced EMF. So your EMF graph would look exactly the same, but it will just have a higher value. Is it making sense?
Yes.
So this is your Vmax, and this is your negative Vmax. And the only reason why it's said to be negative is because during that half of the cycle, the current is flowing in the opposite direction. And your induced EMF is always opposite. What I'm going to do now is I'm going to draw these two graphs on top of each other.
Right.
I'll explain why just now.
But you said the other one's small. Rather it's the
No,
same
I'm
size.
just copying the V graph.
They can be similar.
Oh, that's what you mean.
Oh, that was cold.
That's cold, actually.
So excuse me the squiggle on my curve. It shouldn't be a squiggle. It should be a smooth curve. But you understand where I am at now?
Uh-huh.
Okay. Are you ready for it?
No.
All right.
Let's go. So you can calculate the distance between the
from the talking, I think you are ready for the next.
Yes.
What the signal?
Okay. Right. There is a quantity that we measure called the rate of doing work or the rate of supplying energy. And if the electricity is off, we'd say, I have no power. So there is a relationship between power, current, and potential difference. What is it? Power is equal to what?
It is equal to what?
I know.
What is the
V
unit?
times I. Listen, observe closely now. If I take the blue graph's values and I multiply it by the red graph's values, I am going to get power.
Yes, I know what's going
Okay? I'm not done yet. Hold it. If I'm taking on the negative side of my alternating currents, electricity, the current and the voltage, negative times negative is positive. So this graph looks like this. So this is the power curve.
Double yes.
Are you with me? So it is an alternating current that is being created by this generator. It's creating electric current that changes direction. And in tandem with that, it creates an EMF. That's actually what is created, which causes the current to flow. But the voltage is always more than the current. Okay? But they are generated in tandem. Okay? When you take the product of the two, you get the power.
So when you were saying if you substitute
The values of the current and the values of the voltage into this equation, you'll get power. So this is the maximum power. Okay.
negative P amps.
You don't get negative power. Because on the negative side of power, current and voltage, the product will be positive.
Oh yes, negative times a negative.
It's called motion.
Positive. All right. Children, we need to go to the next level. Okay. Are you ready to listen?
Lessons of it.
Are you ready to listen now? Listen. Okay. Now, because it's an alternating current generator, the maximum power is not the output power. What you get out is called an average power. Okay. Because this thing fluctuates, it goes up and down all the time. The maximum power is not what is available to be used. Okay? Look carefully now. So this maximum power is not available. It's the average power that's available. If you have two quantities and you want average, you say it is a half. of what is maximum?
2.
So it is a half of V max times I max. Are you following what I'm doing?
Trying.
So your average power is half of V max I max.
Why is it a half full?
Because that is just the way it is. Average power is a half of the maximum power. And what is the maximum power? It is V max times I max. See,
So it's half full.
V max times I max will give you P max. But P max is not available because this thing changes in strength all the time.
So we get it half full.
So we have to go for the available power is the average power, which is half the maximum power. Hold it, I'm not done yet. Please keep your attention here. In mathematics, we know that a half is the root of 2 times 1 over, it's 1 over root of 2 times 1 over root of 2. Now current and voltage don't like being treated
Like math.
differently. So it is the root of 2, 1 over the root of 2, V max, times 1 over root of 2, I max.
Where does the root come
seems a bit
in?
redundant.
Why?
No, it's not. Wait. You are just wanting to fight me.
Okay, wait. Let's do your root of 2 first.
May I?
Go on. This is giving me pause.
So technically, you're taking the V max and you're dividing it by the root of 2. Technically, I'm just going to rewrite this equation. V max divided by the root of 2 times I max divided by the root of 2. Okay, the value is going to come in now.
Hey, easels. What's the unit for power?
What?
Come on.
W-A-T-T.
You just said it in the answer now. What is the unit for power?
It wasn't asking me, I was telling you.
I'm not done yet. Okay. This is called the root mean square potential and the root mean square current. So this is V R M S
What the?
times I R M S.
So it's the root average.
Rotations.
square
Root mean square
is mean average.
voltage. Yes.
Yeah, so it's root.
Root mean square. Is it making sense now? I mean, it's brand new to you.
Very. Very brand new.
So ma'am, all of that was just to change the words.
It was to explain how we got there.
Yeah.
All of this is making
equation?
meaning to this.
Which equation is that? The
So
equation
the
we
average power is equal to the product of the root mean square voltage and the root mean square current.
Hold on.
You may as well. That's how we each up.
Okay, sorry.
Root mean.
Okay. Wait for you before you say it. I just want to put these equations on separately. So your I RMS is the maximum current divided by the root of 2. And your VRMS is your maximum voltage divided by the root of 2. And they together give you the P average. The average is IRMS times VRMS. I just swapped the two quantities around. It doesn't make a change.
What's the significance of the root of 2?
Pardon?
What role does the square root of 2 play?
The square root of 2, the square root of 2 times the square root of 2 gives you 2. And that brings you to the half. Yes, that's where it comes from, the half being split into 2 parts. But it must still be a half.
Oh, so the half is standard part of the
A half, the average power is the available power, and it is half the maximum power. So your average power is half of the maximum power. But that equation is nowhere on a data sheet. And the reason for us having to calculate average power is because that is the available power to the circuit. Even though the current is doing this and the power is doing this, not all that power is available to the appliances. So that is why it's important to be able to calculate average power.
So we use the half. We use the half because P max equals to V max times I max.
Yes.
So once we get our P max times I max, we halve that to get our P max.
It's not going to be as simple as that, but yes, that's the basics of it. Yeah. Okay. Now, you see, if I could just explain this. A DC generator would give you not altogether constant current. A DC generator gives you this current, am I right?
Yes.
But somewhere there is the output. Okay. So they compare the energy that is generated by the alternating current to the energy that would be generated if it was a DC current supplying the energy. Okay, go for it. I want to hear. What are you giving me first? Core current or voltage? The definition. Okay. Of what? Current or? Aha, yeah. The root, mean, square, potential, of an AC generator. Okay, you'll have to help me out. What is the root mean square?
The RMS potential difference is the AC potential difference, which dissipates or produces
The
same amount of energy as an equivalent. Same amount of energy as an equivalent DC potential difference.
The root mean square potential of AC is equal to a DC. So it's an AC is equal to DC.
okay. So the root mean square. The VRMS is the. What did you say?
AC potential difference, which
The root means square potential difference. Okay, say it again.
Is
Is the AC
AC
potential difference which dissipates the same amount of energy as an equivalent DC potential difference. If you know one, the other one is easy. What will the other one be? The
Square currents.
root mean square current is the AC current which
Alternating current.
dissipates the same amount of energy as an equivalent DC current. Amen.